Okay, 3G, is it the screen and visible? Okay, cloud security. Good morning to all of you. I'm Ojus Thomas Lee, Associate Professor in CSE, College of Engineering, Kidangoor, presenting you a cloud topic called cloud security, and I have an overview based on the 5th module of CS468, an elective paper for IT students. So this is the syllabus for the security in the cloud. Today I'll be covering cloud security challenges, security as a service, security governance, risk management, security monitoring, security, then data security, application security, and virtual machine security. So the main reference text I'm using is Cloud Computing Implementation, Management and Security by John Rittinghouse and James F. Ransom from CRC Press. And wherever required, I've used other website references, and those website references will be displayed in the appropriate slides. So coming to the introduction, cloud is a boon to new generation technology, but if it fails to ensure proper security protection, cloud services could ultimately result in higher cost and potential loss of business, and that eliminate all the potential benefits of cloud technology. Now, defining cloud security, it is a set of control-based technologies and policies adapted to stick to regulatory compliances, rules, and protect data, application, and cloud technology infrastructure.
So, excuse me, sir.
Yes.
And the screen on the share ചെയ്യാമോ PPT?
Oh, okay.
Okay, sir.
Sriji, is it clear? Is it visible?
Yes, sir. Full screen like ഒന്ന് മാറിയാ മതി.
Okay. So you have so here you have the cloud security. It's not a single program or process. It's a set of control-based technologies, and together with the policies for applying this technology, so that we can stick to the regulatory compliances and rules that is valid in the industry, and these can be used to protect data, application, and the cloud technology infrastructure. Now we move to the security challenges. The security challenges are many security challenges are there. I've listed a few. So the first thing is that the physical security. When you are in the cloud, normally when you are on premises, the physical security can be provided. You can ensure that the security is for your system, your servers, you access to your server rooms, etc. can be physically secured. But in cloud, it is not possible. That is one of the main challenges. Then second is that when the shared resources, when you are using or when you are deploying your application and data in cloud, especially in public cloud, you are sharing the resources. So when you are sharing the resources, you don't have knowledge or control of where the resources run. The third one is vendor lock-in. The vendor lock-in is that normally when you use a cloud service provider, you have to make sure that the data or the application that you store, that you deploy in a service provider, can be migrated to some other service provider if in case the service provided by the current service provider is not up to the mark. So that is the vendor lock-in. That is vendor requires that the data to be stored in a specific format which is not acceptable or migratable to other service providers. Next is integrity of data. Integrity of data means that whenever whatever data you store, the data is stored in the same way, same as the same content is stored, and the same content is delivered when you retrieve it. So, and this ensures and this requires that only authorized transactions can have access to the data. The next challenge is access to log. Now, access to log is very important to ensure the security, to see who all has access to the log, then what all events are happening to the application and data. So security managers need to make sure that you make sure that to negotiate access to the providers logs as part of any service agreement. Then frequent update of application. Normally in cloud, the versioning that we see with the current softwares is very frequent. That is, new versions of the data comes very frequent based on the security updates. So if your data, if your applications is not properly updated, security problems may arise. Then data compliance. The data is still the full responsibility of the compliance for compliance. The data owner is still fully responsible for the compliance. The data owner cannot escape. So this data compliance may vary with the place of storage. So wherever the data is stored, the data owner is responsible. Then next is isolation of virtual machines. Virtual machines is a backbone of cloud computing, but the virtual machines run in multiple virtual machines can run on single server. So since the virtual machines of multiple firms, which may be rivals, can run on co-located environment, and there must be mechanism to ensure that the isolation of co-located VMs, that is VMs which are running on the same server, should be isolated. So next we move to security as a service. Now, security, as we have seen, there are a lot of challenges in the cloud. So physical security is not possible. So the most probable thing is security is provided as a service. So security is an outsourced service where a third party handles and manages the security of a company. A simple example is providing an antivirus support over the internet. Now, conventionally, what we do is that we have the virus protection software, spam filtering software, and other security tools on each machine or on network or server in workplace, and we have to make sure that these softwares are kept up to date. The security as a service allows you to use these same tools using only a web browser and making it direct and affordable. Now, the benefits of security as a service is that you always work with the latest and the most updated security tools available. You don't have to bother about whether your antivirus software is updated. You have the latest antivirus software and etc. The next is get the best security people working for you. Since the security people working on in security as a service will be more experienced than what your IT team has. For provisioning, every service offering can be provided to users instantaneously. The users don't bother about updations. You don't bother about installations. Now, focus on what's more important on your organization. You don't have to bother about installations, updations, etc. You can directly bother about more things on your organization. To save on cost, you don't have to invest on a lot of hardware and software licenses to ensure your security. The capital can be used for some other purpose, and a share of that is goes for the security as service. Then offerings is that, then the security as a service offerings. So till now what we have seen is the benefits. Then now we are coming to the offerings, what the service security as service offers. The disaster recovery and business continuity. If some disaster hits you, maybe a computer virus, a power outage, or a natural calamity, how to restore back your service. That will be security as a service can help. Then continuous monitoring. Since the server since your application is deployed on the cloud, you have to have continuous monitoring regarding the security. Then data loss prevention. Tools protect, monitor, and verify the security of all your data, whether they are they are in storage or use, is provided by security as a service. Then, of course, email security, encryption. Then identity and access management. As far as identity and access management is concerned, your data, since the data is stored in or application is deployed in cloud, identity and access is very important. You should permit only those authorized persons to access the application and data. Then intrusion management. Intrusion management on the cloud is detected, and using the pattern recognition method, and they not only detect intrusions but also help to manage them. Then the network security, then security assessment. Security assessment audits the current security measures you have in place to see if these are compliant with the industry standards. So security assessment checks your existing security provisions in your application, in your data, or for your data, and then it checks to see if it is complying with the industry standard. Then security information and event management. So in order to ensure that the data, the security of data, the security of your applications, you have to manage the log. So since the cloud, on a cloud, a large number of data users access, it is very difficult to access the log in a normal way or analyze in a normal way. So as a service offers to aggregate, to use tools that aggregate the log and event information so that you can analyze data in real time. Then vulnerability scanning. It identifies the vulnerabilities of your network or IT infrastructure on cloud. Then web security. It gives protection for online application. That is the applications that you have deployed on cloud. Now you have seen the security as service. Now, who decides how we decide about the security? That is what security governance tell you. So security governance is an attempt to emphasize that security needs to be managed and governed through organization, not just in IT department. So here the IT department does not mean the IT department in academics, but the IT department which handles the IT requirements of a company. Now, security governance is a committee, or it is a team which analyzes the security with respect to how it is with respect to the policies of the organization. Now, security governance is a collection of practices related to supporting, defining, and directing security efforts of an organization. Throughout the organization, what is the security governance to be done? That is what security governance is doing. Now, security governance is closely related to and often intertwined with corporate and IT governance. So it's a mix, it's a teamwork of the management and the IT team. Now, the principles for security governance is establish organization-wide information security. So every the top level management to the IT team should be informed and should be aware of what should be the information security plans, and uh, uh, that should be intertwined and with the business objectives. Then adopt a risk-based approach. The security governance should think of should think of should think of including should think of resources and budgets, and should be based on risk appetite for an organization. So it thinks of the number of risk that is there for an organization. Next is set the direction of investment decisions. Information security investments are intended to support organizational objectives. So it should be appropriate to the organizational objectives. And next is ensure conformance with the internal and external requirements. The external requirements include like mandatory legislation, regulations, and internal requirements like organization goals should be conformed with. Then security positive environment for all stakeholders. The security requirement of all the stakeholders, including the developers, the clients, the server, the service providers, should be taken care of. Then review performance in relation to business outcomes. And the governance executives should review the performance of the measurement program for monitoring, auditing, and improvement that links information security performance to business performance. How the new plans has affected the business performance, or how it has how does it impact the business performance? That is what review performance is doing. Now the desired outcomes is the strategic alignment. The information security strategy and policy should be aligned with the business strategy. Second is risk management. We'll come to this risk management detail in another slide. So risk management deals with what are the risks, how they are managed, and how they are monitored. Resource management, it's a key goal of information security governance is to align information security budgets with overall enterprise requirement. How the security funding is managing with is mapped with the enterprise requirement. Then value delivery. What is the benefit, or what is the how much resource objectives has was deal what is the value that, or how much value that you got by applying the security. Then performance measurement. The enterprise needs metric against which you judge the information security policy to ensure that organizational objectives are achieved. Now, risk management. Now, every business management, or every business has got their own risk. Now, when it comes to cloud, the risks are more. Cloud-based information systems are exposed to threats that can have adverse effects on organizational operations, organizational assets, individuals, and other organizations. So, how this is to be managed, especially because it is on cloud, it is off the premises. These risks should be managed, and we should have. Otherwise, malicious entities can exploit both known and unknown vulnerabilities to compromise the confidentiality, integrity, and or availability of the information that is stored, processed, or transmitted by those systems. Now, how the risk management is done? You need to perform the following steps. That is, risk management has got the following steps. First is risk assessment. Second is risk treatment. Third one is risk control. Now, risk assessment is done using analyzing the environment to identify the potential vulnerabilities. Then you level the risk. That is what is the impact that a risk gives. Based on that, you identify the level of the risk. Now, once the risk has been assessed, the risk treatment starts. The risk treatment means how the effect of risk is reduced. What are the policies and what are the plans to reduce the if such a risk happens, what should be done or how it can be done. Now, you have to implement these policies and plans. Then you assess the plans, and then you go to authorize the cloud applications and data use policy plans. Now, the risk assessment and the security risk management or the security is a war against unwanted access. In that, risk assessment and risk treatment are post-war planning. Now, risk control is the war front. You monitor the risk, you survey the risk, you identify events, you review the events, and you identify the policies and review the policies. So that is what risk control happens. And these three together forms the risk management. Now, security monitoring. What is security monitoring? Security monitoring is also referred to as security information monitoring or security event monitoring. Involves collecting and analyzing information to detect suspicious behavior or unauthorized system changes on your network, defining which types of behavior should trigger alerts and taking action on alerts as needed. Now, security monitoring, why it is required is that you have, as you told, the risk management you have done. You have the risk control. In that risk control, you have to monitor the risk. Monitor the risk where you actually monitor the risk. Risk means actually security issues. So these security issues or security monitoring cannot be done with the help of human administrators. So for that, you need automation, since when you are deploying your application or data on the cloud, especially in public cloud, you have lot of users for that. So it is not possible by human to manage this security. So you need some kind of automation for monitoring the security, and that is what is called as security monitoring. So it collects and analyzes information to detect suspicious behavior or unauthorized access, system changes, and defining which types of behavior should trigger alerts and taking action on alerts as needed. So that is what security monitoring is doing. Now, challenges of cloud security monitoring. Now, the first challenge is virtualization. All of you must be knowing that virtualization is a backbone of cloud computing. Now, that backbone itself creates security issues for monitoring, because this virtualization gives rise to what is called as virtual machines. Virtual machines are virtual computers running on physical machines. Now, these virtual machines are accessed are normally cloud applications run on virtual machines, and whenever on demand or in dynamic environments, the number of virtual machines increase and decrease. So to monitor that is a difficult process. Next is visibility. Since the cloud stack is on a remote machine and access to every layer of the stack is difficult, the visibility also is minimal. So that gives that is a problem, potential security flaw. Then shifts in security scope. Now, applications and assets normally move between systems which may not necessarily have the same level of security monitoring. So in that case, also the security monitoring is difficult because it may shift through, or this application may go through different security environments. So some security environments may stop the monitoring, some other may be permitting, some other may be giving false information, or etc. So that security shift, that is what is data security. Now, data security is a very important problem as regarding cloud applications. Now, because lot of data is there, is generated and stored on cloud. People rely more on cloud because the applications can use data in an easier way. With data is so huge that people doesn't have enough space to store data. All these, because of all these cases, lot of data, and people want to have the data accessed on the go. So in order to do that, this data should be available on the cloud, so that the people, wherever the people go, the people can have access to their data. But this convenience come with a problem, that is the data is not secure. Not just your data can be accessed not just by you, but by others also. Others can use the data for legitimate purpose or illegitimate purpose. So, or that is, this data can be used for malpractices also. So, the data security is very important. Now, traditionally, it was focused with the firewalls and intrusion detection systems. That is not sufficient for APTs, advanced persistent threats, privileged users, and other insidious types of security attacks. Advanced persistent threats actually stands for security threats through social applications. Now, the challenges in the cloud are regarding data security. Now, need of protecting confidential business, government, and regulatory data. Now, how do we protect? You have restrictions like storing the data in a particular country. Some business data that is being stored cannot be revealed, but the government wants to get it revealed. The data should not be otherwise. The government data should be confidential, but hackers want to have access to it, or hackers try to access to it. All these things happen. That is a real challenge, because data is supposed to be the oil of the new era. Now, cloud service models with multiple tenants sharing the same infrastructure is a data security challenge. So I have told you earlier, we have the virtual machines. Similar to that, a particular application might be having multiple users. A particular cloud service model have got multiple users, SaaS or PaaS or IaaS services, all are having multiple tenants. When multiple tenants are there, there may be tenants which purposefully becoming a tenant in that application or in that service model to have access to whatever other applications are there. Then data mobility and legal issues related to such government rules as European Union Data Privacy Directive. Now, recently we must have heard about the European Union data privacy rules, where the data should not be should not be solved, should not be released to other persons unless the client permits that, and the data should be placed in should be kept in the country of origin, etc. So these standards are data security challenges. Then The other thing is lack of standards about how cloud service providers securely recycle this space and erase existing data. So how this data can be when the data when the disk or disk when you withdraw data from when you withdraw data, how this data is a disk space is used. How do you erase this? Even if you know that even if the data is erased, data can be read. So how do you ensure that the data is not lost from cloud service providers when they discard their disks or disk spaces? Now, other challenges are auditing, reporting, and compliance concerns. So, even during auditing or reporting process, the data can be insecure. Then the loss of visibility to key security and operational intelligence. Since it is not on premise, it is off the premise. The visibility to key security and operational intelligence data is a problem. Then a major problem that we face is that a new type of insider who does not even work for your company but may have control and visibility to your data. So you store data. One fine day you find that you have the data being is available to someone else without your knowledge, but without breaking your service, without through your access control itself. So that is a case where you have a new type of insider. Now, how do you protect your data? Now, protecting of data can be done through implementing a data security strategy that provides a veritable firewall around the data itself for comprehensive protection. Now, simply you can say that you have to, wherever you store your data, you have to have a firewall around your data. Whatever data access, whatever access happens, each of these access should go through a firewall only. It's like you can say veritable means it's something like virtual kind of firewall. Actually, then next is robust access control and well-protected key management. As we have already seen in the access control, who is authorized to access the data, who is authorized to use the application. So that is to be very clearly defined, and only authorized users can have access to it. And similarly, you have the key management, encryption key. How how protected your key management is. Otherwise, your entire process of encryption will be invalid. Then stick to all the regulations regarding data compliances, including the data privacy, clearing of data, etc. So these three steps, three methods for protecting data on the cloud. So maybe there are a lot of other methods, components of these methods which can be used to protect the data. Now we are moving to the cloud application security. Now, cloud environment, you have multiple applications being deployed by different companies. And when these companies deploy applications, the data is shared amongst the companies, amongst the applications. Now, for example, a particular portal or a particular website or a particular portal or application may take data from multiple other applications, which are sources of data. So there comes some kind of collaboration, that is exchange of information. A simple example you can say, when you go for Amazon purchase or an or an e-commerce purchase, you have your e-commerce site collaborating with your bank site. So how secure is the exchange or the collaboration between your applications? So that is what cloud application security means. It is a series of defined policies, process, control, and technology governing all information exchanges that happen in collaborative cloud environments like they have given examples: Microsoft Office 365, Google, G Suite, Slack, Box, etc. Like these are some examples only. Now, the cloud application security threats. Configuration of cloud application setup. Now, since the application is on the cloud, any modification in the configuration can lead to data breaches, or the services are accidentally exposed to public internet, which leads to data breaches. Second thing is unauthorized access to websites. So we have seen that once unauthorized access or unauthorized persons access the data, the unauthorized users can create a lot of chaos. Next is insecure APIs and interfaces. Now, all cloud services are accessed via APIs, that is application program interfaces, or application program interfaces are interfaces of cloud applications. So, if they are not secure, then these APIs can lead to data breach, or application breaches. Then account hijacking. Account hijacking is feared because so much sensitive data and resources is stored and accessed on devices shared by many different users, and because keeping tabs on rogue employees is difficult. So this account hijacking can be done from inside your company itself, and this can lead to legitimate access to sensitive data and resources, and this data can land up in unauthorized persons. Now, cloud application security, how do they do it? The security features and requirements are defined, and application security tests results are reviewed. So you find out what are the security features and requirements required, and you test the application security. The application security process, secure coding guidelines, training, and testing scripts and tools are built as a collaborative effort between security and the development teams. So development team is not working as a single isolated team. They have consultations. Based on the consultations from the security people, they form the security process, secure coding guidelines, etc. Now, external penetration testers are used for application source code reviews. So you have you hire external people, external testers to have testing to see what is the security of your application. Now, penetration test provides an objective review of the security of your application. Now we come to our last topic, that is the virtual machine security. Now, as we have seen, virtual machine is a backbone of cloud computing. Virtual machines are actually OSs, or virtual computers, which run on top of physical computers. We use virtual machine monitors to run virtual machines. So most of the applications on the cloud run on virtual machines, and that helps cloud applications to scale up and scale down. That is scalability. So whenever you have more demand, you can your number of applications running on virtual machine, or number of virtual machines running with your application increases, and when you are less demand, the number of virtual machines that is not required is removed. So it is this virtual machine which is home for your application. So the security of virtual machine is important. So sorry for some spelling mistakes or grammar mistakes. So cloud. So here in virtual machine security, we look into two security features. One is when the virtual machine is working. Second one is when the virtual machine migrates. Now, how the virtual machine security? How is it done? The first thing is when it is running, the data center security teams, replicate typical security controls for the data center at large to secure the virtual machines. Now, data center, the virtual machines are run on servers, and these servers are kept in data centers. So the security teams in data centers ensure that these physical machines and therefore the virtual machines are secure. And they also advise their customers on how to prepare these machines for migration to the cloud environment, and when appropriate. So when these virtual machines are brought to the cloud environment, what is the preparation to be done? This includes firewalls, intrusion detection and prevention, integrity monitoring, and log inspection, all deployed as software on virtual machine. So earlier it used to be a firewall for a couple of machines. Now here, each virtual machine having all these tools. Now increase the protection and maintain compliance of integrity of servers and application as virtual resources move from on-premise to public cloud environments. Then enable critical applications and data to be moved. Critical application data to be moved to the cloud securely. So these features are required when you have the cloud, when your virtual machines are running. Now, when you are trying to migrate virtual machines, the virtual machines need migration when, as we have already told, virtual machines need to be like some of the virtual machines. These virtual machines run cloud applications. So when there is more demand for cloud applications, more virtual machines comes. When there is less demand for cloud applications, then some of the virtual machines are closed. So always you want to have multiple the minimum number of physical machines that use the virtual machines to be working. So sometimes you want to move the virtual machines from one physical machine to another physical machine. That can happen in the case where the disaster happens also, or faults happen. In that case also, the virtual machine migration is required. Now, the problems or the cyber attacks that are specific to VM migration are spoofing, that is mimicking a server to gain unauthorized access. That is something similar to the man in the middle attack. The spoof, when you are moving a virtual machine from one server to another server, you have another third server taking the role of the destination server and taking the virtual machine. So this is what is called as spoofing. Then trashing is that a sophisticated denial of service attack. The attack interrupts the migration at calculated intervals, so the migration is continually restarted over and over, consuming extra compute and network resources as a result. So this is a process where you repeatedly have some application, some kind of interruption happening, which requires that the application, which leads to repeated request for VM migration. Then smash and grab, forcing a source into a better state for the purpose of disrupting operations. So you have some virtual image migrated from one source to another source and to one source destination. So at source or destination, you destroy or you distort the virtual machine image and then thus disrupt the entire process. But in between, a third party, that is a third party or the attacker, can take the data from the virtual machine. So these are the cyber attacks and now how they can handle it. Now spoofing can be handled by using proper authentication protocols integrated within its migration process to prevent this class of attack. Then crashing can be done by automated migration requests throttled to prevent network congestion and avoid overloading the single host. Now, automation, that is what the thrashing happens. Like you have happen, some issues. So thrashing happens. So avoiding such kind of automation request is how we can prevent thrashing. Then smash and grab. To avoid smash and grab, first before initiating a migration, you should regularly create snapshots of the important VM image. Now, snapshot means at a particular instant, what is the status of the VM machine, including the application and the data. That is what snapshot. Now, second, many hypervisor tool stacks support customization of migration process via scripts. So it generally takes care. The data transfer is taken care by the script. Then third, the hypervisor tool stack may delete all the VM image after completion. So normally a smash and grab actually distorts the migration and leads to leaving the old VM image unattended in the VM in a server. As a result, the attacker can take the VM image. In order to prevent this, the hypervisor tool stack can delete the old VM image after the completion of the process. So, so that is all about we have come to the end of the session. Now I think we can go for some questions.
Yes, sure, sir. We have
Yes.
got some questions from students. So,
Yes.
so a student asked, who performs risk management?
Actually, risk management is to be done primarily by the management itself, and then in collaboration with some security experts or security providers from outside. Based on that, the risks are identified, and then their risks are identified, and then we go for the risk as the process, the steps that we have defined, the risk assessment. We go for the risk assessment, then the risk implementation, and then the risk control. So it is actually the initiation should come from the firm itself, and then it should be in collaboration with an external third party who is expert in cloud security. This can be done. I think I have answered the question.
Okay, sir. Then another question is, why VMs need migration?
Okay, I think I've given a small explanation in the question in the course itself. VMs are actually virtual machines which are running on physical machines. Physical machines simply means servers. So when, for example, if you take the case of an Amazon Web Service or an Amazon, for example, an Amazon sale, like you have the sale, 2-day sale, 3-day sale, etc. Then actually, normally what happens is that millions of lakhs of people try to gather or get purchase lot of items. So at that moment, you have a lot of rush coming to your server, and normally what happens is that the server will not be able to manage the load, and the server normally slows down. So the response will be very low. As a result, this can lead to the customer loss. In order to avoid this, when you deploy application on cloud, you have what is called a scalability. That is, your application will be deployed on a virtual machine, and when more requests are there, the more virtual machines are run, so that these requests are given uniformly across these VMs, so that the delay is not there. So when these 3 days are over, there is no more requirement for the virtual machines. Then what happens is that some of the virtual machines need to be switched off. So actually, some of the virtual machines need to be migrated from some servers to another server. Now another, that is what is one VM migration is called. Now another case is that, like, when some kind of server failures happen or some kind of disaster happen, you may have to go for migrating VM from one physical machine to another VM of physical machine. And this VM migration can be done either when the VM is switched off or when the VM is running. So that depends on the scenario. Okay, I think that's answer for that.
Okay, sir. Then we have a question from different security levels in cloud computing. The question is,
Okay.
there are different security levels in cloud computing as it is seen from your PPT, and how is it different from one another? That's the question.
Okay. So security levels is like you can say that you actually the security level is actually based on what is the impact of that particular risk. Like you can see that there are security risks like very critical, medium, average, very low, like that. If you put that security levels like that, so if some event which happens, when some risks that happen or some security event that happen affects the entire system, then it can be grouped into the very high critical class. If it is very low, if its impact is very low, then we can put it in the low priority level. So that is the range. It depends on the levels classify the security event as to how it affects the application or how it affects the data which is being secured. I think that's the answer for it.
Okay, sir. And we have some more questions, and I think we have a bit more time. So I'll move on to the next question.
Okay.
How we ensure that
Okay.
our deployed applications are safe in cloud?
Now, now the deployed application is safe in cloud. Actually, that is what we have to. That is to be taken care by the service provider. Now, when we deployed application in service provider, actually, what happens is that the data can be lost. The application can be have unauthorized access. So while designing the application, we have to ensure that this application is to be gone to the cloud, and then accordingly security measures are to be made. In addition to that, we have to ensure that the security features, that is, or the security rules that is to be followed is to be ensured. Okay.
Okay, sir. And I think we can take one more question.
Yes.
And the question is, can cloud storage be hacked? So,
Yeah, of course. Everything can be everything on cloud or everything using computers can be hacked, because actually there like the people normally do research on, like people do research on actually the security measures come up only through this hacking, because only then actually this hacking is, there are two ways, like the ethical hacking and otherwise. These hacking shows the vulnerabilities. So like even whatever be the vulnerabilities that we handle, or security measures we take, still there are chances for security, the cloud storage or whatever be the thing, there are chances for hacking. So every time, even if you ensure that every measures are every security measures have been taken care of, but still we have to have security monitoring to see that there is no hacking or similar kind of thing happening. And we have to see that even if something happens, how we can find out solution for that at the earliest. Okay, I think that's the answer for that.
okay, sir. Then one more question recently appeared here. So, who is a cloud
Okay.
service provider, and what should I ensure from a provider for my safe storage of information?
So that depends upon the service provider is like you can see service provider for storage. You can say Amazon Web Service, Amazon S3, EC2, Amazon Glacier, etc. All these are services provided by Amazon. Then Microsoft Azure, Google Storage, Cloud Storage, and lot of other. I mean, even you can say your Dropbox, your Google Drive, etc., can also come into the category of cloud storage. And it depends upon the type of the application and the client that we use. How, whether if it's a desktop application, probably smaller cloud storage service providers can be used. If it is a large service provider, if it is a very big application which wants to have lot of storage data storage coming, and has got scaling required, you have to go for higher end data storage service providers. I think that is the answer for that.
Okay, sir. Okay. So I think it's time for us to conclude. We had some more questions, but I think we'll later answer to them. And so, so I'd like to
Okay.
say that as industries and enterprises are nowadays shifting towards this cloud technology, I think the students have to get a deep knowledge in this subject, and we really had an interactive group of students for this session. So we are so happy for your questions and doubts, and I think all are cleared for you. And so, sir, I
Okay.
and one more thing to add that I don't know whether you have just noticed it that we had some reference text and a reference link in the bottom of all those slides, so students can make use of that. And sir, thank you so much for adding that in your slides. And
Okay.
so I think we
Thank you.
can wind up. So I'd like to thank you, sir, on behalf of SAP